Welcome to this short demonstration video for the OneBenthic Sediment Change tool. So this tool is designed to look for evidence of change in sediment composition between one or more baseline surveys and a monitoring survey. And it can be used to monitor changes in sediment composition within marine licensed areas or marine protected areas or even research sites. So I'm going to give you a quick demonstration. So in the first step is to select a sector. So in this case, we're going to look at the aggregate sector, and then you have to identify the baseline survey and a monitoring survey, or if there's more than one, you can select multiple surveys. In this case, I know which surveys I'm going to look for, but if you didn't, you can get that information from the map. So there are different activity layers here which you can turn on and off. So for example, wind farm areas or aggregate extraction areas. And so if you have a particular area in mind, let's look at wind farms, for example. So this is the Triton Knoll site. So you could then turn on your samples by checking the box here, and then you can use the drawing tool just to draw a box around the area of interest. And if you go over to the search tab, you'll get a list of all the samples that fall within that box, and that will crucially give you the survey name. So in this case, E1411. So you can scroll through here, see what surveys have been undertaken in the vicinity of that site, and then you can decide which ones you want to compare. So let's just go back a little bit, we'll turn these off, go back to our example. Okay, so in this case we're going to look at the Anglian aggregate dredging region. So, and I happen to know the names of the surveys here, so I can just start typing Anglian into the box there, and I'm going to pick this one. This is the baseline survey done in 2014-2015, and then select the monitoring survey, which the latest one was in 2018. And you'll see that the samples for those two surveys now appeared on the map. So the baseline samples are in blue and the monitoring samples are in turquoise. And then you've got two further choices to make here. So, well, things you have to select. First is the RSMP array name. So in this case, it's the Anglian. And then if we zoom in, you can see if I turn on the activity layer, so the PIZ, the SIZ, and the reference areas, you can see that there's a lot of stations here where we've got both a baseline and a monitoring sample, but there are one or two where you've only got one or the other. And so you can decide to use all the data, so that's what we're looking at here, or you can just take the paired sites. And in this case, we're just going to take the paired sites. So that will remove any stations, any samples where there isn't both a baseline and a monitoring sample. So having made these selections, you can look at the data tab, and there are 4 tabs underneath that where you can inspect the baseline samples. So each row is a sample. The monitoring samples, under this tab we join them together, and then in this tab each sample is assigned to a treatment category based on the polygons that are relevant. So if a station falls within an SIZ, it will be assigned to a treatment category for SIZ. And we've got treatment categories for these polygons and for time as well. Okay, so now we can do the actual analysis, and the analysis will run once you've clicked on the results tab. And for the aggregate industries RSMP, that's Regional Seabed Monitoring Program, we get outputs at different spatial scales. So we can look at the data by region, so that's all of the sites lumped together, by sub-region, for example, the South Coast and the Humber, where the aggregate licenses are clustered in sub-regions. It's not relevant for the Anglian, but and then it's obviously a site level as well, so we can look at results for individual extraction areas. And the analysis only run once you've clicked on the relevant tab, so you have to be a little bit patient. So let's first of all look at the outputs here. So the first thing we're looking at is these line plots. So these show the mean sediment composition for all all the samples that fall within the PIZ at the baseline and for monitoring. And also, we see this output for secondary impact zones and for reference sites. And if there's not much evidence of change, you'd expect these to be overlapping, which is what we see here. And if there were some big changes going on, you'd expect these lines to be separated. In the next tab, we've got a table of means. So this is just the mean sediment composition. So we're looking at the Wentworth size classes here. So this is silt clay, fine sand, medium sand, coarse sand, fine gravel, medium gravel, and coarse gravel. And yeah, these are the mean values by treatment class, and you can also see the number of samples that are involved in that assessment. So quite large. In the next tab, we've got a multi-dimensional scaling ordination, and this will take a little while to run. So we'll come back in a moment. Okay, welcome back. So the analysis is now run, and a series of plots has appeared, and you get an individual plot for each of the treatments here. So the PIZ, the SIZ, and the ref. And so what these plots show is the similarity or dissimilarity between groups of samples. So each of these dots represents an individual sample from either the baseline or monitoring. And what we would expect if samples are similar between the two surveys is for them to overlap. And that's what is happening in these plots. So there's no obvious separation of baseline and monitoring samples. And the way these ordination plots work is they take multi-dimensional data. So we've got 7 different sediment fractions, and it allows that information to be plotted in 2 dimensions. So each of these axes represents a combination of those variables. So on the face of it, it looks like conditions are pretty similar between the 2 surveys, but we can test that statistically using an Anazim test. And what the Anazim test does is it gives us two outputs, an R value and a P value. And the P value is the statistical significance. So anything less than 0.05 is statistically significantly different. And the R value is really the effect size, and that ranges from 0 generally to 1. So if it's 0, it means there's no real change, and if it's 1, it means that there's a big change. And so you can see here that some of the p-values for these treatments are greater than 0.05. So in that case, there's no evidence for change. But down here, we can see that this one has a p-value of less than 0.05. So it is statistically significant, the result, but you can see the R value is very close to 0. So essentially, we can say that's similar. So this column here, the interpretation, looks at the combination of the P and the R value, and we'll come up with an interpretation automatically. And the colours here are based on a sort of traffic light approach. So we've got actually 5 different interpretations going from no evidence of change or similar, which is green, up to different, which would be red. So what we do then is where we do find differences, we want to know which sediment fractions are responsible for those differences, and we look at that using a SIMPA test. But in this case, we don't have any treatments where you've got that scenario. So when we click on the SIMPA tab, there's nothing to show. And also, similarly with the change tab, so if there were any sites where there were statistically significant differences with an R value greater than 1, that would show up in SIMPA, and you'd see a bar chart as well. So, but that's not relevant here. So what that means is that at the regional scale, there's not much evidence of sediment change going on. But of course, we can now look at this at the site-specific scale, and we can click on the Site tab. And we can look through the series of plots again. So here we've got our line plots for each of the extraction areas and their secondary impact zones. So we interpret these in the same way as we did for the region. So if there's not much evidence of change, we'd expect the 2 lines, the mean lines, to overlap. If there was some evidence of change, then perhaps they would separate, but of course we have to think about how many replicates are involved in that comparison. We've then got our table of means again. So this just shows the mean sediment composition by treatment group. Our NMDS plots in 2 dimensions again. So in this case, rather than lumping all the data together, we've got individual subplots for each site and treatment. So for 2.1.2, for example, there's a plot for the PIZ, and there's also a plot for the SIZ. So this gives you some idea of whether sediments are similar or whether they're different between the 2 surveys. And for the site scenario, we've also got a 3-dimensional MDS plot, and you can move this around so you can explore the data a little bit more. And the way to use this is really just to turn off all the values. I won't do it here, but you can turn them all off, and then you can turn on a site of interest to explore it a bit more. But it just means you can sort of move it around and get a better understanding of how those samples are separated. We've also got the Anazim results, and in this case we can see that there's no evidence of change at most of these sites, although here we've got a significant p-value and an r-value of more than 0.1, so that means that there's some evidence of a bit of change going on there, or difference. So really only the one site, and we can see these results in the map by clicking this button, and you can just toggle these on and off. So you can see that everything seems to be, or no evidence of change or similar where it's green, and only this one site where there's a little bit of difference, but again it's considered to be quite similar. And then here's the SIMPA tab, and you can see that here we've got one location where there are some differences, so that's taken forward to SIMPA. And you can see here that the sediment fraction most responsible for the differences is medium sand. And then you can see how the sediments have changed between the baseline and monitoring surveys. So, and when looking at this graph, we should really look at this in combination with the SIMPA result. So that's it. Thanks for listening.